Bismillahirrahmanirrahim. Assalamu alaikum class. Today we will discuss pharmaceutical pre-formulation. Before going to discuss the pharmaceutical pre-formulation, let us have an overview of physicochemical properties. Physicochemical properties of a drug are concerned with its solubility, with bulk, with chemical aspects. The soluble related physicochemical properties are overall solubility, like in water medium, in polar and non-polar solvents, dissolution, partition coefficient between the lipophilic hydrophilic phases, between the you can see overall its tendency towards the hydrophobicity or lipophilicity, or the its tendency towards the you can say the hydrophilicity, and pK value, and bulk related are the flow properties. Overall is its density, particle size, bigger, smaller, surface area, crystallinity, concerned with the crystal, phases, angles, polymorphism, hygroscopic properties, compatibility, drug excipients, like which are the delivering for in order to pass the drug molecule through the body, how drug will be administered in the body along with certain um, chemicals which are used for the delivery purposes, and they may be from the certain origin, like which may be uh, positive, or the you can say plus effect on the body, or they may be have negative, and therefore excipient is a substance which is formulated along with the active ingredient of the drug, and for its long term stabilization and solid formulation, and they may be like bulking agents, fillers, diluents, and the chemical related are the like process may occur like decarboxylation, racemization, photolysis, breakdown in the presence of light, enzyme inhibition, like when these are investigated in vivo studies, oxidation, hydrolysis of certain bond, and the isomerization. Next is the pre-formulation. What does uh, it mean that how these pre-formulation methodologies are necessary in drug discovery and moving towards or designing towards a new drug candidate, and at the next step uh, demonstrating these drug you can say candidates as the drug molecules. And pre-formulation is the group of studies, and these studies focus on the physicochemical properties, and these physicochemical properties I have enlisted in the last slide, that these are the multiple properties concerned with the chemical and the physical aspects of a drug candidate that could affect the drug performance and the development of the dosage form. Drug performance mean how how the drug molecule will exert the pharmacokinetics, pharmacodynamic phase, and the development of the dosage form, how the drug will be administered in the body, that it show the maximum therapeutic action, like in the form of in the form of tablet, in the form of capsule, or in the form of injection. And this could to provide important information for the formulation design, and or the sport, the need for the molecular modification. It means that at this stage the molecular modification can be done, and every drug has intrinsic chemical and the physical properties, and which has been considered before the development of the pharmaceutical formulation, before the drug coming into the market, and this should be sold under a certain brand name. Before solding the drug or trading it, such type of the pre-formulation steps should be done, that the drug's chemical and physical properties should be investigated in a very well way. If these investigations or the experimental procedures don't show that the drug are up to the certain standards, then there should be the movement towards the formation of analogs, which show the better drug delivery process, which can be made part of the cells, or the have the more capacity towards the receptor binding. And this property provides the framework for drugs combination with pharmaceutical ingredients in the fabrication of the dosage form. And it means that while synthesizing a dosage form, the drug for which it will be available in the therapeutic window, or provide a better therapeutic index. And therefore, drug with pharmaceutical ingredients mean active ingredient, excipients, fillers, etc. And these are also important for the designing, for the fabrication, or for the dosage form. And the objectives of the pre-formulation study is to develop the elegant, stable, effective, and the safe dosage form by establishing the kinetic rate profile, compatibility with the other ingredients, and establish physicochemical parameters of new drug substances. It means that under the pre-formulation studies, what are the what with developments comes under it, that the drug should be stable one, it should be effective one, it should be administered in the body in a safe dosage form. The dose must be in the therapeutic window. It shouldn't be very high to exert its toxicity, or it shouldn't be very low that it doesn't impart any effect on the receptors, or any effect ailment to cure certain ailment or the disease. And it should be it's established after the kinetic rate profile, and compatibility with the other ingredients, like other if co-administration is done, or the compatible, it doesn't show a bad impact. And therefore establish all its physicochemical parameters, physical chemical properties, which I have listed. And among these properties, drug solubility, partition coefficient. Drug solubility is important, because if drug is not soluble, water will not take it. Water is, because the in blood large concentration of the water is present, then the drug will not be absorbed efficiently. And if its lipophilicity is low, then it will not cross the membrane. And similarly is the partition coefficient, in order to predict its lipophilicity and the hydrophilicity. And the dissolution rate, if it is unable to dissolve in the body, or in the acidic medium, or at the physiological pH, then how it will be made part of the cells or the organs, different organs, to metabolize it and then distribute it, and lastly to impart its therapeutic function. And polymorphic forms and the stability. If the drug is not stable, if it will going to be breakdown, then breakdown mean if it is metabolized, or the digestive enzyme will act, or certain other enzyme will lysis the bond, hydrolyze the bond, then what will be the purpose of the drug? All the drug administration will result in the failure. and the polymorphic form in present in the more different forms, and these different forms are originated from the crystalline structures and different latest properties, and and therefore these all play an important role in the pre-formulation studies, and these pre-formulation studies are very important in order to go through before using of so much energy, time, and personnel efficiency. And polymorphism is the ability of the solid material, here the drug, to exist in more than one crystal form or the crystal structure. And because these different crystal structure or the allotropic form, they refer to the different chemical, physical, aspects will be, their physical properties will be changed, or and so the stability will definitely be resulted from the different chemical bonds and so on. And the polymorphism having crystal and the having crystal structure and the amorphous form having no crystal forms show different chemical, physical, and the therapeutic description of the drug molecule. Therefore, if the drug, these binding capacity or the arrangement of the atoms or the different bonds at different angles, different different bond lengths, they will definitely have an effect on the physical, chemical, and also the therapeutic properties or medicinal importance of the drug molecules. And pre-formulation evolved in the late 1950s and early 1960 as a result of a shift in emphasis in industrial pharmaceutical product development. In industry, when the certain pharmaceutical product or like certain drug, it may be like Brufen, when they are going to be formed in very large in bulk amount in the thousands bags, and these type of the pre-formulation studies which investigated the physicochemical properties, they were found necessary in late 1950s and early 1960s. Before this, there was a little bit less concept of this pre-formulation procedures, and it was improvement in the analytical methods that outgrowth the first programs that might bear the name pre-formulation. It means that analytical method, there are many analytical methods which are no doubt correlated with the synthetic procedures, many analytical procedures, many analytical devices, they all are part of the chemical synthesis or the organic synthesis, and therefore they are the first programs that might bear the name the pre-formulation. And overall objectives of pre-formulation testing is to generate information useful to the formulator. Formulator means who is formulating these drugs, who is synthesizing, who is going to be marketing these drugs. In developing stable bioavailable dosage form, bioavailable mean if the 50 500 milligram of augmentin or certain other drug is going to be used, and if only 50 milligram is available, it means that its bioavailability is very low. uh, Whatsoever is taken, if it's 500 milligram, then no doubt there are certain the fillers excipients as well, but the active ingredient should be high one. And therefore the objective of the pre-formulation testing is that the drug must be in a certain formula, and that it should be stable one, it should be shouldn't be break down before reaching its target, and its capacity to bind with the target should be high in a very optimum concentration. And during the early development of the new drug substances, the synthetic chemist alone or in cooperation with the specialist in other disciplines, including pre-formulation. In other discipline mean synthetic chemist is also collaborating with the uh, like physicists, like mathematicians, or other like biochemists doing in vitro in vivo studies of these drug molecules. Therefore, the early development of a new drug substances, they synthetic chemist alone or in cooperation with a specialist in other discipline, including pre-formulation, may record some data which can be appropriately considered for the pre-formulation. It must have sufficient amount of data regarding the physicochemical properties, regarding the drug's therapeutic index, regarding the like solubility, stability, its partition coefficient, its like overall crystal structure, its polymorphism. These all parameters should be in his or her mind, and these they must provide a sufficient data regarding this, because this all data is responsible for the for holding the like at the later stages for the formulation of the drug in the bulk amount. And before starting the pre-formulation studies, we should know the properties of the drug. Properties, which type of the properties? It means that as long as the therapeutic properties are concerned, for which purpose, like antibacterial, antiviral, anti-inflammatory, analgesics, which type of activity it will impart or show or display, and potency relative to the product competitive product which is available in, and in comparison to it, what potency of this drug which you are going to be pre-formulated, which it will show, and the dosage form, in which dosage form it will be utilized, and literature search providing stability, and the decay data. Decay data mean again the stability and also the like hydrolyzing of certain bonds, a half-life period, the proposed route of drug administration, like enterol and the parenteral administration, and literature search recording the formulation approaches. After the pre-formulation, there is formulation of the drug in the like many units, industrial units, and its bioavailability in the body, and the pharmacokinetic phases of chemically related drugs. If chemically related drugs like its analogs are already present in the market and they are also utilized, then what type of the pharmacokinetic mechanism they are showing, how they are taken, how they are absorbed, distributed, eliminated, and these type of the investigation must be done, and data must be collected from the extensive literature survey. And preliminary investigations are, it also include preliminary investigations that before starting it, there must be some investigation, literature survey, molecular optimization by the drug. And these molecular optimization are also considered in the drug like molecular modeling, which should be tested to determine the magnitude of each suspected problem area. It means that problem area at which what you want to do, what will be the outcome, and what type of the problem you will face in these investigation, and what at which intensity, at which magnitude, and if a deficiency is detected at the certain areas, and therefore the molecular modeling should be done in order to you can say investigate or make certain other analog, other molecule which have the better properties, which have the better coordination with the receptors, and which has better 3D-dimensional structure, bond lengths, bond angles, and therefore the stability as well. And to overcome these deficiency, molecular modification is done. Molecular modification means that you are going to modify the basic preliminary or the basic nuclear structure. I have used this terminology many times, that basic moiety, and you will work around this moiety. You will do modifications, and these modification may be done by salts, by salting, as by forming a salts, like if acid is there, react with base to yield salt, and vice versa. And you can go towards the pro-drug formulation. And Prodrug is no, must be done for a certain drug molecule which have the low stability, or which have the active ingredient has not the better taste, or has not the better solubility. Such type of the parameters are low, and the solvation process like solvates or the polymorph, different crystalline structure may be modified out, or even the new analogs can be synthesized. And the dissolution rate of the salt form of the drug is generally quite different from that of the parent compound from that salt formation is resulted. Dissolution rate is very important because we have investigated, studied it many times. If the drug dissolution rate is low, it will not be make the part of the bloodstream, it will not be circulated in the systemic system, it will not reach its target in order to impart its medicinal effect. Like the sodium and potassium salt of the weak organic acids, and hydrochloride salts of the weak organic bases. It means that with the organic acid, you will react it with the bases to form the salt, and with the organic bases, you will react with the like HCl to result its salt, and dissolve much more readily than that the respective free acid or base drug. Like here is quoted the example of the ephedrine base, and for example, what in his what's shown over here as its solubility. For example, ephedrine base is very poorly water soluble molecule. Here is the structure of ephedrine without the HCl molecule. And ephedrine, it's a base, and is its solubility in water is very low, poor, and that is characterized by the low solubility and low dissolution rate. So it is modified in the form of salt, which is the ephedrine HCl. The formula is given here, and and EHCH3 and CH2CH3, it's the basic and because of the amino group, and it's reacted with the ACl to give overall the salt, and it's now called the ephedrine ACl, that is ionized and offer higher water solubility and higher dissolution rate when it's in the form of the salt. And the prodrug formulation is the formation of the synthetic derivatives of the drug, like esters, amides, and therefore they liberate the active ingredient when the drug is administered, and some bonds are going to be break while they are in the in vivo in certain organism in like human being. And the active drug is released by the acidic medium, or by the released by the acidic medium mean like in the stomach where pH is low, by a certain enzyme. And the prodrug formulation may increase the absorption rate due to its lipophilicity. I have told you earlier that if the drug absorption rate is low, then it's make more lipophilic. Lipophilic means it can easily pass through the membrane, or its water solubility like the active. And the prodrug formulation may increase the duration of action. Prodrug formulation may result in the duration of action, like uh, uh, if the drug is only showing its action for the 4 hours, but by due to the using of the prodrug, its duration of action may be prolonged for 8 hours. It means that now the drug dosage form may be given like after 8 hours, not after the 4 hours. Um, Drug is sustained in the body and therefore increase the duration of action. And product formation may improve the drug stability, its solubility, crystallinity, taste, odor, and reduce pain on injection. Reduce pain on injection mean when it's going to be injected, it is injected in such a way that the prodrug, if the original drug is injected, it may causes lot of pain, but due to the in the prodrug formulation, this pain is reduced. And for example, the erythromycin base has a bitter taste and is rapidly hydrolyzed in stomach to inactive products because stomach hydrolyzed it, low pH hydrolyzed it. But erythromycin estolate, which is a prodrug on the erythromycin, it's an inactive and tasteless. It means that the bitter taste is replaced by the tasteless, and the activity which is going to be enhanced in the stomach, which is stomach breakdown. It when stomach breakdown, it means that drug is no longer a drug. It's going to be changed into the metabolite which are inactive one. Therefore, it's you can say taste maybe going towards the better situation, tasteless, and no longer breakdown in the stomach. It has 4 times absorption more rate, like its simple base, and it is hydrolyzed by the acid in stomach to liberate the free base, which is the active one. And therefore, the estolate definition is it's the docile sulfate salt of the propionate, especially of the erythromycin. And here is the on the left side there is overall structure of the erythromycin simple, which is the base, whereas on the right side it's the erythromycin estolate, and it is in combination with the docile sulfate, which is the estolate. And therefore in this case it's the prodrug formulation, and it's the you can say the absorption rate is enhanced. Next is the physicochemical parameters. It's the organoleptic properties, bulk characterization studies. And under bulk characterization studies, there are up to G parameters. And before going this, you must know what are the organoleptic properties. Organoleptic properties are in fact the aspects of like food, water, or other substances that create an individual experience, and these experiences are through the senses like taste, sight, smell, and touch. And bulk characterization is like crystallinity, crystal structure, more than one crystal form, property to absorb water, hygroscopic, fine particle characterization, uh, what type of particles are there, bulk density, powder flow, if present the powder, what are the powder flow properties, compression when it's going to be compressed in the form of tablet, how it will bear the pressure, and the physical overall description. And number third is the solubility analysis. Among the solubility analysis, it's the intrinsic solubility determination, pK determination, partition, coefficient determination, responsible for the water solubility and the membrane passage, and the dissolution studies, common ion effect. If other drug or other like sodium, potassium, certain ion are present, what will be effect on the drug solubility, and the stability analysis in toxicological formulation, and solution stability. What will be the solution stability? What will be the solid state stability? These two stabilities are different. Number first is organoleptic properties, and I have told you these properties are concerned with the like color, which are through the senses, sight, taste, smell. And first is the color, and also human being, all human being like the better colors, appealable colors, and it should be unappealing to the eye, and determined by either instrumental method or the visible methods that varies from batch to batch. It means that color determination, organoleptic properties are important for the pre-formulation studies. And record of early batches and establishing the specs is very useful for later production. It means that if the early batch, like if the four batches are formed on the first day, and their color are not good, they are not appealing towards the eye, it means that first batch data must be before you, before going towards the next batch formation. And the specs mean they are referred to the specifications. What are the original specification, how they look like, and it's very useful for the later production, like for the later batches synthesis. And coating of a body in a variable color can be done if found undesirable. If original color of the active ingredient is not the good one, it's not appealing towards the eye, then in this organoleptic properties studies investigation, the industry or the pharmaceutics must go towards the formation or the coating of the active ingredient into the variable different colors. Like here is given in the picture, the tablets are in the different colors, and which is good towards the eye. Their VN is appealing, or the better color, pleasant, giving pleasant feelings to the body. And odor and taste, it obviously the odor must not be bad. Um, they shouldn't be pungent and like, and the taste must not be so sour or bitter. And for unpalatable drug, that you can't take them uh, because their taste is not good, use of the less soluble chemical form or suppress it by the flavor. Certain flavors are given, like the banana flavor, mango flavor, and such type of, if the active ingredient have the better have not the better taste, it's have the bitter taste, bad taste, it may be coated with certain excipients, fillers, and coatings may be imparted. And the drug substances which irritating to the skin should be handled with the precautions, like flavors, dyes, excipients used will affect the stability and also the bioavailability. And color may be off-white, like cream, yellow, tan color, shiny. Odor may be pungent, sulfurous, fruity, aromatic, and the certain drugs are also, the active ingredients are odorless. And taste may be acidic, bitter, bland, intense, sweet, and tasteless. Next is the bulk characterization studies. And what does bulk, as bulk mean big, large? Then bulk characterization studies of the drug molecule. It involves the characterization of the various solid state properties of the drugs, and that could change during the process of drug development, and it is needed to identify all the solid forms that may exist as the consequence of the synthetic stages. such as um, if the synthetic protocols have been done, that such as the presence of the polymorphs drug compounds may be formed. Bulk properties such as the particle size bigger, smaller, they are important. Bulk density, what is its density? Surface morphology may be changed during the development process, and to avoid mislead prediction of the solubility and the stability, which depend on the particular crystalline form. It means that a particular crystalline form have a more, you can say, solubility, more stability, and the bulk characterization testing overall includes these like crystallinity and the polymorphism, in which crystal form the drug is present. What are the different crystal? You have studied the system: cubic, tetragonal, rhombic, orthogonal, and what will be the overall habits, and the structure of the solid compounds referred to as the crystallinity, and the like crystal forms, and these structure disappear when the drug molecule or overall any substance go into the liquid or the vapor form. They are the properties of the solid forms like crystal form structures. It can be classified as the internal structure, which is formed due to the different bond lengths, bond angles, due to the cubic, tetragonal, hexagonal, rhombic, and the solid habits. What are the habits? Like platy, needle, appearance, tubular, in the form of these drug molecule may be synthesized in the form of prismatic, prism shaped, bladed, and changing the, this point is important, changing the internal structure, like the if the shape internal structure is going to be changed from the cubic to the tetragonal, rhombics, and so on. It may also alter the crystal habit, like the crystal overall appearance, like the tubular, prismatic, these may be converted. And changing the chemical form, like salt formation, it also alters both the internal structure and also the crystal habit. It means that these all properties are interlinked with one another. And different polymorph are obtained by the crystallization from the different solvent, like different solvent may be imparted, may be used while crystallizing these drug molecules, and by solidification after melting. First melt them, then solidify them, then you will get the different crystal form, different polymorph form. And when the incorporated solvent is water, then they are, we will say that the hydrates are formed, and the compound not containing any water within the crystal structure, it means that it's an anhydrous one. An atom in the crystalline matter are arranged in the regular repeating pattern in 3 dimension structure, and for example metal and the minerals and atoms or the molecules, if the randomly placed without a regular atomic arrangement in the amorphic solid, will be originated. And the polymorphism is the ability of the compound to crystallize as more than one distinct crystalline species, and with a different internal lattice structure, with different crystal forms, which have at the different free energy states of the same compound, and therefore they have different physicochemical properties, like if polymorphic form or crystalline form is different, it means that due to the different lattice like energies lattice form, they have the different melting points, they have different densities, vapor pressure, they have the different x-ray, overall structures, color will be maybe changed, crystal shape may be changed, hardness, their compressibility, solubility, dissolution rate, and bioavailability in the body may also be changed. And during the pre-formulation, it is important to identify the polymorph that is stable at the room temperature, because all drugs are placed on the room temperature, and it's important that the drug must, if it's not using it's on the shelf, it must be in such a crystalline form that must be very highly stable till many months at the room temperature. And for example, example is quoted here for the chloromephanicol, which exists in A, B, and C form. And only the B form is the more stable and the preferable form. And the riboflavin has also three forms, but the third form shows 20 times more water solubility than the first form. And therefore, the enantiotropic polymorphism, morphic morphs can be interconverted by only below melting point, and either of the polymorph will be formed in case of the enantiotropic. And here is given the structure of the chloromephanicol and the riboflavin. And chloromephanicol, it's the antibiotic which is useful for the treatment of number of bacterial infections. And riboflavin is the vitamin B2, and it is the vitamin which is present in many foods which you daily take, and it's used as the dietary supplement. It's all about the pre-formulation, and for assignment, uh, provide the answer for the following. Why is the pre-formulation necessary, and how is the pre-formulation made? You have to give the different ways, different means. It's all about today's lecture. Best wishes and Allah Hafiz.